All right, today we are doing a deep dive into RF over fiber technology. We're looking at the source material on the Thor Broadcast F-RFOF-4GHz-TXRX kit, which is essentially a transparent RF fiber link.
And, we really have to start with the problem it's built to solve.
The core problem.
Exactly. When you try to send high-frequency signals, the RF part, down a standard copper cable, you run into this wall. It's just a massive amount of signal loss.
The signal just dies out over any real distance.
It degrades so fast. So these kits, they completely solve that distance transport problem by switching the medium from electricity to light.
Right. And this specific kit, it's covering a huge range, 100 megahertz all the way up to 4 gigahertz. I mean, what does having that much spectrum available actually let you do?
Oh, it's a game changer. It means
Right.
a single link can handle almost anything you throw at it, basic communications, certain defense bands, satellite signals. It replaces a whole bundle of specialized copper wires.
So it's like a universal utility pipe for wireless signals?
You could think of it that way, yeah.
But it's not just about the distance or the bandwidth. You mentioned the quality of the signal is just fundamentally better than copper. Why is that?
Well, it really comes down to immunity.
Immunity.
Copper is electrical. It's vulnerable to outside electrical noise. EMI, RFI, electromagnetic, and radio frequency interference. It's like trying to have a conversation next to a running jet engine.
So it's like a laser beam just cutting right through all that noise.
Precisely. The sources talk about the unit's great EMI design, but the fiber itself is naturally completely immune. Plus, this unit has a very flat frequency response, so the signal stays true across that whole 4 gigahertz range.
And the applications list we have here is, it's pretty extensive. We're seeing communications, defense systems, GPS.
And satellite links? L-band and S-band are specifically mentioned.
What are those used for typically?
They're crucial for satellite communications and certain types of remote sensing. But maybe the biggest application today is modern cellular.
For the distributed antenna systems. DAVAS.
Exactly. This is the tech that links a main base station to all those little remote antennas you see. It's how you get solid 4G or LTE coverage inside a big building, or say a subway tunnel.
Okay, that makes sense. So knowing that, let's dig into the specs a bit. The source says it works up to 20 kilometers, but, and this is a big, but only over single mode fiber.
Yes.
So wait a minute. A lot of older corporate networks use multi-mode fiber. Isn't that a huge hurdle for anyone trying to upgrade?
It can be, logistically, but for this kind of performance, it's a non-negotiable technical choice.
Why is that?
Multi-mode fiber, it has an issue called modal dispersion. The light pulses basically get smeared out over distance. If you want a clean 4 gigahertz signal over 20 kilometers, you just have to use single mode. There's no way around it.
I see. So it's a necessary trade-off for fidelity.
It is.
What's also fascinating here is the efficiency. The operating temperature is really wide, minus 20 to plus 50 Celsius, and the receiver's power draw is just 1 watt.
1 watt. Max?
That's nothing.
It's incredible. That 1 watt figure changes everything for remote deployments. You can run these things off a small battery or a tiny solar panel. It simplifies all the logistics.
And for the connections, I see standard SMA 50 ohm on the electrical side and FCA PC for the optical. Why APC specifically?
The A is for angled physical contact. That angled polish on the connector tip minimizes light reflecting back into the laser,
Which keeps the signal clean.
It's all about maintaining that signal integrity from end to end.
So to pull it all together, we have this tiny, rugged box that gives you 4 gigahertz of bandwidth over 20 kilometers.
With total immunity to electrical noise and barely sipping any power, it just rewrites the rules of RF transport.
It really does. So here's something for you to think about. If a tiny, low-power link like this can robustly carry signals for 20 kilometers, how much does that change our idea of remote infrastructure? Is the future less about building complex sites and more about just powering these tiny, almost disposable high-performance links?